This is problem number 2 from section 5.1. In this problem, they want you to estimate the area under the graph of f of x equals 5x cubed between 0 and 2 using finite approximation below. So they want you to do lower sums with 2 rectangles, lower sums with 4 rectangles, and then upper sums with 2 rectangles and upper sums with 4 rectangles. It's very similar to the previous problem. The first thing we want to do is start to draw these pictures. So I think let's go ahead and draw the lower sum graphs. Lower sum graphs. So lower sum graphs, first of all, if I have 2 rects, I would have a graph that looks like so, where I have 0 to 2. If I start here, this is a cubic, so because it's a cubic, this upper right hand side that we're looking at basically looks sort of like a quadratic. So at 2, if we plug in 2, so if we look at what f of 2 would be, I'm going to plug this in. So f of, I might just write these. We know f of 0 is 0. F of 2 is, well, that's going to be 5, 2 cubed, which equals 5 times 8, which is 40. So we know that this is 40 up here. So our graph is going to look like so. Looks kind of like a quadratic here. So for 2 rectangles, and if we're doing lower sums, our 2 rectangles have to be the same width. So we're going to have 1 being the middle. Each one's going to have a width of 1. Because it's a lower sum, we're going to make sure that we start at 1, we go up until we touch that function, and we slide over. And so our rectangle has to be below the curve at all times. And then our other rectangle, well, its height, if it's any more than 0, right, for this width, if it's any more than 0, it goes above the curve. So it's actually just got a flat line right here. So it's just got an area of 0. So our 2 rectangles here have basically 0 area and then some area right here. If we do the lower sum for 4 rects, or just draw the graph of 4 rectangles, we're going to get the exact same graph. So I'm going to go ahead and draw 0. This is 2. So that's 40. The difference, though, is with 4 rectangles, we're going to split the width into 4s. So 2 divided by 4 is a half. So we're going to mark this at a half. We're going to mark this at 1. So this is 0.5. This is 1. This is 1.5. And our rectangles are going to look like so. Up till I touch the graph. Up till I touch the graph. This one here. And then finally we have 0 there. So you can see there are just 4 rectangles in there underneath the curve. Let's look at the upper sums then. So upper sum. So same graph each time. We've got 0, we've got 2. We draw this quadratic looking function here. This is 40. But now we're doing an upper sum. So we're splitting the width again into 2 rectangles. So this is for the 2 rectangle version. But we're doing an upper sum. So now instead of it being below the curve, we're going to allow it to be above the curve. What's the biggest rectangle we can make there? So the biggest rectangle we can make would be using, instead of the inside version here, we're going to use the outside version. So we're going to go up all the way to the top and over. That's our first rectangle. And then we're going to touch here wherever 1 touches the function here. And that's our second rectangle. And then if we draw our last graph, we've got 0, we've got 2, and this looks just like the other ones. So that's 40. And we're doing upper sums, but we're doing it with 4 rectangles this time. Split this into 4, so this would be 0.5, this is 1, and this is 1.5. And you can see my upper rectangle will be here. The next rectangle is there, and then finally we have one that goes right here. Now it kind of looks like 0 just because my graph's not very good. There's actually some area there. There's some area there because you can see that little gap there. It's just above. So we need to go through and we need to find the areas for each of these. Well, to do this, let's go ahead and find, we know that we're going to need to find f of 1, we're going to need to find f of 0.5 and f of 1.5. So f of 1 is going to equal 5, 1 cubed, so 1 cubed is 1, so that's 5. Okay, f of 0.5. F of 0.5 is 5 times 0.5 cubed. Let's see, 0.5 cubed, half times a half is a quarter, times a half is an eighth, so it should be 5/8, or 0.625. Let's see here, 0.5 cubed times 5, 0.625. And then finally, let's do f of 1.5. F of 1.5, I'm not going to write out us plugging it in. We know we're taking 1.5 cubed. So I'm going to say 1.5 cubed times 5, and that's 16.875. Okay, now we know everything we need to know for this problem, essentially. So let's go ahead and find these rectangles. So we know rectangle 1, its area is going to be its width times its height. Well, we know the height is going to be f of 1. So our width here we know is 1. So area, we're going to say rectangle 1, and actually I'm going to write area is 1 times, because that's the 1 here, 1 times 1 times f of 1, sorry, I lost my train of thought, 1 times 5, which equals 5. So our rectangle 1's area is 5. Our rectangle 2, sorry, I screwed that up. That's rectangle 2. We're going to label these. That's 2, that's 1. All right, rectangle 2's area. This one right here, that's rectangle 2, 1 times 5. My bad. This rectangle 1 area would be 1 for the width times 0 for the height, so we end up with 0 there. So when we find the actual area here, we're going to have the total area being 5 plus 0. Now this is area, I'm going to say under, because it's area under the curve. So 5 plus 0 is 5. And we can write that for the lower sum, we're going to get an area of 5. Okay, for 4 rectangles. Now I'm just going to say areas here, and then I'm going to write the areas underneath. Now we're going to label this 1, 2, 3, 4. So rect 1, R1, its area is going to be essentially its width times its height. Well, its height is 0 there. So we end up with 0. For R2, we have a width of, screwed that up, width is 0.5 there. Our width here is 0.5 times its height. Well, its height is f of 0.5. F of 0.5 is 0.625. So we have 0.5 times 0.625, which gives you 0.3125. For rectangle 3, its width is 0.5, its height is f of 1. Well, f of 1 is 5. So 0.5 times 5 we know is 2.5. And then for rectangle 4, again, its width is 0.5. So we're going to take 0.5 times its height. Well, its height is f of 1.5, which is 16.875. So 0.5 times 16.875. And we end up with, so 0.5 times 16.875. We end up with 8.4375. So my area under is 0 plus 0.3125 plus 2.5 plus 8.4375, which equals, so 0.3125 plus 2.5 plus 8.4375 is 11.25. So we have 11.25 here for that area. Okay, now these are, you can see with two rectangles, our area estimate was 5. With 4, we get a better estimate, 11.25, a lot better. And you can see it's covering more area. Now these ones are going to be overestimates because these are the upper sums. So for this one here, we're going to say areas. And this is 1, rectangle 1, and this is 2. So rectangle 1's area is going to be 1 times f of 1, which we know f of 1 is 5. So that's just 5. Rectangle 2, width of 1, times f of 2, which we know f of 2 to be 40. So times 40, which is just 40. So we end up with our area under being 5 times 40, which is a huge overestimation of, that would be what, 5 times 40 would be 200. So it's way too big, right? But you can see all this extra area that they have in there. Look at that. That's extra area right there. Okay, that's area that shouldn't be there. But you look here, and now our extra area is a lot smaller, right? We don't have near as much extra, so this one will be a better estimation. We'll slide over just a little bit. So this is areas, and this is going to be 0.5. So rectangle 1, let's label that 1, 2, 3, 4. So we're going to have 0.5 for rectangle 1 times f of 0.5, which we know f of 0.5 is 0.625. And we know that that equals, so 0.5 times 0.625 is 0.3125. So rectangle 2, we're going to have 0.5 for its width times, well, our height is going to be f of 1. F of 1 is 5. And we know that to be 2.5. Rectangle 3, width of 0.5. Our height is going to be f of 1.5, right, for 3, f of 1.5, which is 16.875, which gives you, if you look back over here, we did that 0.5 times 16.875. That gave you 8.4375. And finally, rectangle 4 is going to be 0.5 times f of 2, which we know f of 2 to be 40. So this will be 20. So our area under equals 0.3125 plus 2.5 plus 8.4375 plus 20, which equals, add all those up, $31.25. So you can see this estimation here is a much better estimation than our 200 estimation that we had for the two rectangles. 200 for the two rectangles, that was much larger than the 31.25 we just got. Now we can say from this, because if we go with our best estimation, which is the lower sum, with four rectangles, and the upper sum with four rectangles, 11.25 and 31.25, we can say area is between 11.25 and 31.25.